Hello, this is Mrs. Rutchling, Chapter 9, Electron Configurations. We have looked at all the orbitals, and what do we use them for? They can give the address of the electrons in an atom, and these addresses, or these electron configuration, has to go in order of increasing energy. And we call that the Aufbau principle, because someone named Aufbau came up with that idea. We also learned that there are 2 electrons in each orbital. Why do we care about electron configurations? We need to determine the number of valence electrons. And valence electrons are electrons in the s and the p orbitals of the outermost energy electrons. Those valence electrons will help us determine what the atom's going to do when it reacts and how it can bond. Every atom has its own unique electron configuration. Electrons tend to assume positions that create the lowest possible energy, and the ground state configuration is the lowest energy arrangement of those electrons. So I said the Aufbau, and that is the electron is going to occupy the lowest energy orbital available. The Pauli exclusion principle is that no 2 electrons in the same atom can have the same 4 quantum numbers. So it can have the principal quantum number, it can have the orbital, it can have the orientation, but it has to have different spins, and oftentimes that is shown by the arrows pointing 2 different ways. And depending on what you like, you can do it that way as well. Lastly, we have Hund's rule. We have to fill each orbital in a set with 1 electron before putting 2 in. And all unpaired electrons must have the arrow in the same direction. You are going to need to know these to match them up with the names for our test. There are going to be 3 types of configurations, and it's important to read the question to figure out which one it is asking for. The first we're going to talk about is orbital notation, and it shows us each electron. 1 arrow represents 1 electron, and it shows the spin. So we have the 1s, and they're spinning in opposite directions. Each orbital is written as a line, and then the group has just 1 under it. So for example, we don't write 2p, 2p, and 2p. We just write 1 underneath. Aufbau's principle, first we filled the 1s, then the 2s, and we went through until the 2p, 3s, and 3p. That's in order of increasing energy. We fulfilled Pauli's exclusion. Within the orbital, the arrows are pointing in other directions. If we look over here in our 3p, we have Hund's rule. We can't put 2 in an orbital until we've put 1 in each orbital. Only then can we come back and put another electron in here. In addition, these electrons are spinning in the same direction. Silicon has 14 electrons. How do I know that? I find it on the periodic table. Its atomic number is 14. It's neutral, so there's no electrons added or removed. That means it has 14 electrons. I start with my 1s, that takes care of 2 electrons. Then I go to 2s, 2 more electrons, so I'm filling in Aufbau order. I go to the 2p, and that one is also filled. So I have 2, 4, 6, 8, 10. Now I have 12 electrons, and the last is my 3p. Let's try chlorine. Chlorine has 17 electrons. Start filling my 1s. Then I go to my 2s. My 2p is filled. 3s is filled. 3p, 5 electrons. If I add all of those up, they come to 17. Pause the video and try the orbital notation for these 3 atoms. Double check your work.